Let's work on some examples of mole ratios here. So here I have the equation of nitrogen plus hydrogen gives me ammonia, which is NH3. So when I balance the chemical equation, I find that my coefficient has to be 3 in front of my hydrogen and 2 in front of my ammonia. So if I'm doing mole ratios, all I'm doing is pulling the coefficients and forming them in a ratio based on what I'm asking for. So if I say, in this equation, for every 1 mole of nitrogen, how many moles of hydrogen are needed? You would go to your equation and you would be like, okay, so I have 1 mole of nitrogen, that's good. And then I have 3 moles of hydrogen. So my ratio would be 1/3. So I'm not inventing the numbers. I'm not making them up. I'm literally pulling them from the chemical equation. That's really important to keep in your mind. So when you're setting up mole ratios, you need the balanced chemical equation. End of story. So think about it for a second. If for every 1 mole of nitrogen that reacts, how many moles of ammonia or NH3 are produced? So think about it, pause your video, set up your mole ratio in your head. Okay, so for every 1 mole of nitrogen, 2 moles of ammonia are produced, 2 moles of NH3. Okay, I didn't make it up. I didn't invent the numbers. All I looked for were my coefficients. So if there's no coefficient, we know that stands for 1. We've beaten this horse plenty of times. It knows what it's doing. So 1 mole of nitrogen will, when reacting, will produce 2 moles of ammonia. Again, that 2 comes right from the balanced chemical equation. Okay, same thing. For every 3 moles of hydrogen that react, 2 moles of ammonia are produced. That's a mole ratio. That's all it is. You're just taking the coefficients and you're aligning them in a ratio. And you can go back and forth depending on what is being asked of you. And we'll talk a little bit more about that once we actually get to the stoichiometry equations. Okay, so mole ratio is used to convert the number of moles of one substance to the corresponding number of moles of another substance in a stoichiometry problem. So if you don't have the correct ratio, you won't be able to solve the stoichiometry problem. Okay, so mole ratio is used in the solution of every type of stoichiometry problem, whether it's a 1-step, whether it's a 2-step, whether you're going from atoms to moles, or if you're going from atoms to grams, you need to be able to identify mole ratio. So please go back, rewatch the videos, take a look at the notes, look at the examples. Be sure you know what you are doing here. So with the mole ratio method, okay, so we have this thing called starting substance. So this is where Mr. Cree and I were like, what were you given? So when you read the word problem, what was given in that word problem? That's your starting substance. So your starting substance is what is given. So you have to convert that starting substance into moles if it's not already in moles, okay? Then we take the moles of the starting substance and we convert them into the moles of the desired substance using the mole ratio. And then if we have to, we convert the moles of the desired substance into units specified in the problem. So for the time being, we are really only going to be working on 1-step equations. We're going to be going from moles to moles. Okay. So the first example that we're going to do is going to have you guys go convert from grams to moles using molar mass, but that's practice. That's something that we've done plenty of times before. So when we're determining the number of moles of the starting substance, you have to identify the starting substance from the data that's given in the problem. So that's your given. That's what we've been talking about. That is the given. So if your starting substance is not in moles, we have to convert it to moles, which is what we're going to talk about on the next slide.